So on this quick concept today, we're going to be talking about advanced exponents. So if you want basics for exponents, you want to go back and just watch the exponent video under quick concepts. But I'm just going to call this advanced exponents because we're taking it to the next level with these. So let me show you what I mean. So if we have something like this. So when you're dealing with a variable with an exponent, like x, you can have power over root. So this is what we call the Radican form. And this is called the exponent form. So a lot of times to solve certain things, you need to put it in the exponent form rather than the Radican form. So I'm showing you how to do that. The way I teach my students on how to memorize the power of a root is I'm always saying your power is your flour. So if you picture what a flour looks like, sorry about my drawing here, you have your flour, and then underneath is the roots. So this is kind of what I mean. The root is on the bottom, your power is on top. So it's just kind of an easy way to memorize which goes on top and which goes on bottom. So just picture your flour, which is your power, and your roots will always go on the bottom. So if I were to write this from Radican form to exponential form, I would say 3 is my power. This is a square root, so it's got a 2 on the bottom. 2 is my power. The root is 2. Now this x, on the other hand, there's nothing there, so it's always understood to be a 1. That's your power. 4 is your root. 3 is your power, 4 is your root. Now remember, if there's nothing here, it's understood to be a square root. Sorry about that, which is 2. So make sure you understand that portion. Okay, so now we're back to what I would consider just your regular exponents. So just a little recap of that. When you are multiplying like variables, you're going to add your exponents. So if I want to know what my x's combine to be, I have to add 3 halves plus 1/4 because those are the exponents of the like term. I have to get a common denominator. So this is going to be 6/4 plus 1/4, which is 7/4. So I know in my answer it's going to be x to the 7/4. Now let's try our y's. We have 2 over 2 plus 3 over 4. That's this and this. I'm going to get a common denominator, which is going to be 4/4 plus 3/4, which is 7/4 again. So y to the 7/4. So that's your answer. So let's do 2 more just to kind of shore this up. These are from lesson 5 in your Saxon Advanced Math 1 book, if that helps you, if you want to follow along from there. This is number 7. I did number 7, now I'm doing number 8. So again, as soon as you see this, this is in, a couple of them are in exponential form. These are already in exponential form, so I'm just going to bring them straight down. But the rest of them are what's called Radican form, so I need to bring these down now. So the power of this x is 1, and remember the root is 2 when it has nothing there. And the same for this. And of course this one is going to be the power of 4 over 3. So now I'm ready to add my like variables. So I'm going to start with my x's, and I'm going to say 1/2 plus 3/4 plus 1/2 plus 4/3. So I need to get a common denominator, it looks to be of 12. So we have 6/12 plus 9/12 plus 6/12 plus 16/12. So if I add these up, 6 plus 9 is 15, plus 6 more is 21, plus 16 more is 37/12. So my exponent for x is, believe it or not, 37/12. Now I really don't have to add y to anything. I can just bring it over, and there is your answer. So let's try number 9. That one gets a little more complicated because division is involved as well as a power to a power. Now these are already in exponential form, but we have to add like terms. So the first thing you want to do, and again, this is from your previous exponent quick concept, is we have a power to a power. Whenever you have a power to a power, you want to multiply. So I'm just going to bring the a over, and I'm not going to do anything here, but I'm going to multiply that 1/2 through. So try to think of it like this. So this is going to be y to the 1 minus x over 2 if I ran this through. And then I'm just going to write this down. Now I'm ready to combine. This time I'm dividing like variables. When you're dividing like variables, you want to subtract the exponents. So on top, I need to get a common denominator of 2. So my a is done. My a is going to be to the negative 7x over 2. And for this one, really I can't do anything with the 1 because there's no x in it, so I can't combine it. But here I could go ahead and multiply this by 2 over 2. So it's going to be 1 minus x over 2 plus 4x over 2. And I can combine these. It's going to be 1 plus 3x over 2. And then I can just say 1 plus 3x over 2. And that's your answer for number 9. And that is it for advanced exponents.